So we're gonna start with low voltage battery. No, the is for power supply for the electronics, auxiliary systems, and vehicle start. Okay. The big difference is that this 12-volt battery or low voltage battery, because it's not necessary to be on 12 volt, uh, is for supply the control units of all electric vehicle. No, in order to start the high voltage system. Okay, after the high voltage system start to function, this 12-volt battery is just gonna be in a standby mode. Okay. Uh, the difference between the battery of electric vehicle and the engine cars, okay, is that the battery of the engine cars is for start the for supply energy to the starter. Okay, the starter is an e-motor that is gonna move the gearbox and help to the e-motor to break the inertia of the vehicle. Okay, and here and for that the 12-volt battery of engine vehicles are gonna use big amounts of amperes of current. Okay, uh, here in electric vehicles, the 12-volt battery is not gonna use too much current. So that's another characteristic. They are not have too much capacity as a 12-volt battery of engine combustion vehicles. Okay, they are usually lead acid. Okay, this is the chemistry of we can find in these batteries: lead acid or lithium ion cells. No, so the lead acid is the normal battery that we could find. Okay, and the lithium batteries is this kind of batteries. Okay, so the first difference is this one. If is discharged, we could use a booster or a charger to recharge this battery. But with the ion lithium batteries, also here inside this battery, we have a control system. So what happens if this battery discharge? Uh, well, inside they have a relay, and this relay is gonna be opened. So it's not gonna be possible to recharge this battery. So it's more complex. The system inside these batteries are more complex. Okay, but as I said before, we need this battery because if we have our high voltage battery fully charged and our 12-volt battery is discharged, we are not gonna be possible to start the high voltage system. So the vehicle is gonna be completely dead. Okay, it's very important component, the 12-volt battery. Uh, then uh, let's pass to talk about the high voltage battery pack. No, that is the biggest battery that we have, the storage system, who is gonna storage all the energy of the for the traction of our uh, electric vehicle. Well, regarding to the high voltage battery, we are gonna talk about the RES. Okay, it's rechargeable electric energy storage system. The electric energy storage system, okay, is not only a battery. The RES has three components: the high voltage battery, plus the charging circuit, and plus the control unit. Okay, the control unit who is gonna control all the functions that we have inside the high voltage battery. Okay, the principal function of the RES is provide electrical power for the propulsion of our electric vehicle. Okay, here in the pictures we can observe three different types of high voltage batteries. The first one is in a platform between the car axles. Okay, but as you can see here, in order to use this kind of batteries, we need to delete a lot of mechanical parts. So, in which kind of vehicles we can use this kind of batteries? Well, in full electric vehicles. Why? Because full electric vehicles uh, delete or eliminate all the mechanical parts for the exhaust gases. Okay, so and also we delete the gearbox, so you will have a lot of space uh, to put a battery in all the platform of the vehicle. Okay, but this under the rear seats and under the truck, these small ones, okay, these small ones are for vehicles who are not have too much space, no? So in which case we have vehicles without space? Well, and hybrid vehicles, okay? Hybrid vehicles, hybrid cars, they don't have too much space because we need all the system for the combustion engine, and so we are gonna need the exhaust systems also. So we don't have too much space to put a battery in all the platforms. So we use this kind of batteries. Okay. Now we are gonna talk about the second component of the rest of the rechargeable electric energy storage system. That is the battery management system. In other words, the BMS. BMS is the control unit of the high voltage battery. Okay, it's an electronic device that monitors and controls the battery pack. Okay, what factors is gonna monitor or control? Well, it's gonna be monitoring the voltage of every single cell. Remember, a high voltage battery has a lot of cells, and the BMS needs to be capable to measure every voltage of every single cell. Okay, then the total current of the high voltage battery. Okay, we need to know the total current of uh, all the high voltage battery. No, because if we pass the limit of current, we could burn the battery. Okay, then the BMS is also monitoring the temperature in all the battery. Okay, we have thermopars or thermocouples in all the battery. Okay, and sensors of temperature in order to cooling the battery or calefaction if it's too cold. Okay, uh, because we need that perform our high voltage battery in the range of 15 to 35 Celsius of temperature. Okay, so the battery is also monitoring the temperature of the system. The BMS is monitoring the temperature of the system. Then the battery is calculating all time the battery state of health. No, is seeing the aging or the degradation uh, that we are having inside the chemical. Okay. Or another important value that the battery is calculating is the or estimating is the state of charge. Okay, is how much energy uh, we have in our cells. Okay, how much electrical energy we are storage in our cells. So if we have 100% of a state of charge, it means that our battery is fully charging. Okay, and 0% is full discharge. Okay. Another thing that the BMS is doing is as we monitor the temperature, the battery is going to activate or deactivate the cooling system of the high voltage battery. Okay. Then, an important uh, operation that the BMS do is connect and disconnect the high voltage circuit. How we do it? Well, here uh, in our high voltage battery, uh, we have relays, no? Main relays or main contactors, no? So when we want to connect the high voltage circuit, the BMS is gonna close the main relays and it's gonna supply the energy to the other components that the e-powertrain, for example. Okay, and then let's see the last component of the rest. Okay, that is the onboard charger. What is the onboard charger? Well, the onboard charger is the part of electric vehicles that transfer the energy from the grid into the car's battery. Okay, what is this important? Because as you know, from the grid we receive AC current. Okay, and the battery, the high voltage battery, works in DC current. So, well, every storage system works in DC current. Okay, so we need a component available to transform from the AC current to the DC current. And which one is the responsible to do that? Well, it's the onboard charger. Okay, the onboard charger, if we are recharged from the grid in monophasic, no, in monophasic, that is here in Europe is most common 230 volts, no, in AC, well, we need and our high voltage battery works in in 400 DC, right? The most common value of voltage from for high voltage battery is 400 volts. Okay, so if we are recharging the vehicle in in 230 volts in AC, our onboard chargers needs to be able to transform these 230 volts in AC at 230 volts in DC. Okay, and then of this first transform, the the onboard chargers needs to make a boost of voltage. Okay, it's gonna transform from the 230 volts in DC to 40 volts in DC. Okay, after this after this boost of voltage, we are gonna be able to recharge our high voltage battery. Okay, so inside the onboard charger we have two electronics devices, very powerful, no? Ones that is gonna transform from the AC to the DC, and another DC converter who is gonna transform from the DC to DC, a boost converter. Okay. Then we're gonna talk about more in detail of this. Okay. But the onboard charger is the component for recharge our high voltage battery. And what happens is if our uh, charger supply the current in DC. Well, if the current that the charger give us is in DC, here the energy is gonna go directly to the battery. It's not gonna pass through the onboard charger. Okay, so it's important thing to do. If we charge the vehicle in AC, we are gonna use the onboard charger. If we charge the vehicle in DC, it's not needed to use the onboard charger. It's gonna pass it's gonna pass directly to the battery, to the high voltage battery. Okay.